Let's solve this question. Consider the Kelly tables of three groups. Three groups are given to you: F, plus, G, star, H, dot. So three Kelly tables are given to you, and the question is asking which two groups are isomorphic to each other and why. So the question is asking which of them are isomorphic to each other and why. Let me tell you one thing here. If you notice, this is not even a group, first of all, because in this you don't even have an identity element. So if you look at this Kelly table, this is not even a group because there is no identity element. See, X is not identity element. Why? Because this X is not identity element, because you can notice this column is not same as this header. Okay, so this X is not identity element. This Y is not identity element because this row is not same as this header. This Z is not identity element because this row is not same as this header. So I can say in this there is no identity element. In this there is no identity element. In this Kelly table there is no identity element. So this is not even a group. So remember, this H, dot. This is not even a group. This is not even a group. So actually this question is wrong. See, the question is saying that there are three groups. Actually this question is wrong. Let me tell you. They should say that there are three structures. First of all, I am saying that this question is wrong. The question is saying there are three groups. They should say there are three structures. So this question is simply wrong. Instead of group, they should write that consider three tables of three structures. Three structures. Okay, so remember, if you look at this structure is closed. The closure property is satisfied. XYZ, XYZ, XYZ. The closure property is satisfied. You can check for associative property. But the point is this is not group. The point is this is not group. Okay. And I can say that in this question it is given three groups. So this question is actually wrong. They should not say that these are groups because this is not even a group. The third structure, this is not even a group. Now let me tell you, if you remember, I told you with the three elements, there is only one template for group. I told you that there is with three elements, only one template is possible. Only single template is possible. Remember, only one template is there. Only one template for a group of order 3. I told you that with three elements, only one template is there for a group of order 3. And what is that? If you have a group of order 3, let's assume you have a group and this is your group. Let's assume in a group you must have identity element. So let's assume E is the identity element. You must have identity element. And let's assume these are the remaining elements. And you have some operation. This is the operation. Now, if you see, this is a group. So the Kelly table, if you create the Kelly table, this will be EAB. Now let's create the Kelly table. Now there is no choice because this is the identity element. So this row must be same as this header. So you must have this. Similarly, this column must be same as this header. So you must have this. Now, finally you tell me, remember I am talking about group. So in this row, no element should repeat. Similarly, in this column, no element should repeat. Now you tell me, in this row, no element should repeat. Can I put A here? I cannot put A here because then A will repeat because already in this row A is there. So I cannot put A here. Now, can I put B here? I cannot put B here because already in this column B is there. In this column already B is there, so I cannot put B. So the only choice is E. This is the only choice. This is the only choice. So now I have to put B here. Now you can notice the only choice is E here because the element should not repeat in any column. Similarly, now there is only choice, that is A, because elements should not repeat in any row. So you can notice that only this one group you can create of order 3. This is very important point that I am telling you. We have already seen in the lectures. I told you that if you have three elements in the group, if you have a group of order 3, then only one group you can create. Only this single group you can create. You cannot create any other group. Basically, every group that you will create will have this structure. The point is simple, that order 3 group, there is only one structure possible. There is only one template possible. I can say that only one template there, only one template is possible, or I can say that only one structure is possible. Only one structure is possible. The point is, for order 3, I can say only one non-isomorphic group is there. Only one non-isomorphic group you can create. Okay, so remember the point is that for order 3 group, only one template is possible, only one structure is possible. Means if you see any group of order 3 in your life, if you see any group of order 3, that will always have this structure. Every group of order 3 will always have this structure. It will always have this structure. See, in this structure, if you notice what is happening, in this structure, you have identity element. There is one identity element and there are two remaining element, and you can notice they are inverse of each other. In this structure, you have one identity element and you have remaining two elements, and you can notice they are inverse of each other. Means x inverse is y, y inverse is x. They are inverse of each other, y inverse is x. So this is the only template, this is the only structure you can get for order 3. Means I can say order 3 group. This is the only template. What is the only template? The only template is like this, that you will have 3 elements. One element will be identity element. The remaining 2 elements will be inverse of each other. The remaining 2 elements will be inverse of each other. X inverse will be y, y inverse will be x. So this is the only template possible. This is the only template possible, that you will have 3 elements. One element will be identity element and the remaining 2 elements will be inverse of each other. This template is there. For example, consider this group. We have already seen this is a group because these are the cube roots of unity. I told you that nth roots of unity, this under multiplication will create a group. So this we have already seen that this is a group. Actually, this is a abelian group. We have 1 omega omega square. Remember, these are the cube roots of unity. In the lectures, we have already seen this. We have already seen what is cube roots of unity. But the point is that these are the cube roots of unity. Unity means 1. These are the cube roots of 1. 1 omega omega square. Now, if you see, this is a group. And this is a order 3 group. I can say this is a group and you can see that there are 3 elements in this group. So this is order 3. I am telling you that this group will also have the same structure that we have already seen. This group will also have the same structure. If you create the Kelly table for this group, 1 omega omega square, 1 omega omega square. Let's create the Kelly table. So the Kelly table will be something like this. If you fill the Kelly table, then that will be like this. Omega, this will be omega square 1. And it will be like 1 and omega, so like this. Okay, now omega square, omega power 4, that is omega. So you can see, now you can easily notice that what structure this has. This structure, if you look at this structure, there is identity element, this is your identity element, and there is one element omega, there is another element omega square, and you can notice this is your x, this is your y, because they are the, you can notice they are the inverse of each other. Omega square is, omega inverse is omega square, and omega square inverse is omega. So you can see the same structure this is following. Remember, I am saying that this structure, this is a group. This is a cube roots of unity. In the base set, you have 3 elements, so order is 3. And this is a group. We have already seen this group. The complete analysis of this group we have already seen in the lectures. So this is an abelian group. And if you create the Kelly table, you will get this Kelly table. I am telling you that look at the structure of this group. The structure, only look at the structure. There is identity element and the remaining 2 elements are inverse of each other. The remaining 2 elements, you can notice they are inverse of each other. They are inverse of each other. So if you notice, I can simply say, what I can simply say that this structure that you got, this structure is isomorphic to this structure that we have seen, EAB. You have identity element. So you can notice EAB. Okay, and you can easily notice that it will be EAB, and you can notice that this will be E, this will be B, this will be E, this will be A. Now you can easily match both the things. You can easily match that. Basically this E is your 1, this A is basically your omega, and this B is basically your omega square. You can check it out. Okay, this is omega and that is omega square. So I am saying that this group, this is a group, but this has the same structure as this. Similarly, you can take any other. For example, consider this. We have already seen this is also a group. This is also a abelian group actually. So this complete analysis also we have done. This is your basically Z3. This set is known as Z3. And this is your addition modulo 3. This is the group. Addition modulo 3. Modulo 3. Now remember, this group also has order 3, right? This group also has order 3. So in this group also the same thing will happen. There will be an identity element and the remaining two elements will be inverse of each other. In this also what will happen? See, there is identity element. 0 is the identity element and the remaining two elements are actually inverse of each other. If you find the inverse of 1, that will be 2. If you find the inverse of 2, that will be 1. So you can notice again you are getting the same structure. Again you are getting the same structure, that there is one identity element, you are having one identity element and the remaining two are inverse of each other. Here also there is one identity element and the remaining two elements are inverse of each other. Here also there is one identity element and the remaining two elements are inverse of each other. So ultimately what I am saying, that if you create any group of order 3, every group of order 3, there is only one template possible. Okay, group of order 3, there is only one template possible, there is only one structure possible, no other structure possible. There is only one template possible and that template is this, that there will be one identity element, you will have one identity element and the remaining two elements will be inverse of each other. The remaining two elements, these are going to be inverse of each other. This is what I am saying, that only one template is possible. This is the only template possible. And if you create any structure, for example 1 omega square multiplication, if you create this structure, for example 0 1 2 addition modulo 3, if you create this structure, or if you create for example EAB, where operation is some hash, let's assume, and this is the identity element and this A inverse is B inverse is A. So you can see that all these are isomorphic. All of them have same structure. All of them, they have same structure. They have same structures. Remember, same structure. This is also called isomorphic. Isomorphic means same structure. Okay, so I can say these three, this structure, they have the same structure. They basically have the same property. Means this structure has the same property as this structure has the same property as this structure. So these three structures are same. I can say they have the same structure. I can also say that these are I can say they are isomorphic. These three are isomorphic to each other. So very simple. Now let's come back to the question. The question is asking, so ultimately you can see this is not even a group. So forget about it. This is not even a group. As I told you, in this question, this word should not be used. They should use the word structure. Okay, now you notice, do they have the same structure? Tell me, are they having the same structure? This is a group. You can check it out. This is a group. And you can notice here 0 is the identity element. And remaining two elements are inverse of each other. 1 inverse is 2 and 2 inverse is 1. Okay, so you can see, yes, this is a group and yes, this is your template. You have identity element and you can notice the remaining two elements are inverse of each other. The same thing is happening here also. You have this A is the identity element. You can notice this A is the identity element. So in this also I can say identity element is A and the remaining two elements are inverse of each other. Means B inverse is C and C inverse is B. You can see B inverse is C, C inverse is B. So I can say these two structures are isomorphic. You can see same structure. This structure. Can I say they are same structure? Yes. So you can notice they are the same structure. There is identity element, here also identity element, here also identity element. The remaining two elements are inverse of each other. So I can say that these two structures are isomorphic. So the question is asking which of the two groups are isomorphic. I can say this group and this group, they are isomorphic to each other. Are they abelian? Yes, they are abelian because only one structure is possible for order. You can see only one structure is possible. I told you if you have group of order 3, this we have already seen that if you have group of order 3, only one structure is possible. There is only one structure, or I can say there is only one template. You can say that it is template. and this is your template, that there is identity element and the remaining two elements are inverse of each other. Okay, so this is the template. You can notice EAB, EAB, and you have I can say something like this. So EAB. So I have to put A here, I have to put B here. Now this E and this A. So yes, you can see. So this is the only template possible. This is the only template possible, and you can easily notice this is abelian because this is symmetric. The first row is same as first column, second row is same as second column, third row is same as third column. First row same as first column, second row same as second column, third row same as third column. So you can notice only one template possible, only one group possible, only one group possible, only one template possible, and that is also abelian. That is also abelian. So I can say every group of order 3 is abelian because only one template, only this template is possible, no other template possible, only this template is possible, and this template is also abelian. So I can say every group of order 3 is abelian because for order 3 only this group is possible, only one structure is possible, and this structure is abelian. So I can say every group of order 3 is abelian. So this is the complete analysis of this question.